welcome to The Explainer. Today we're talking about a huge, kind of hidden threat to our digital world, basically a ticking time bomb set to go off in the future. But maybe more importantly, we're going to look at the super clever solution being built right now to defuse it.
Okay, so let's dive right in. To really get a handle on this, we first have to understand the sheer scale of the problem we're up against. This isn't just about some new type of computer. It's about a fundamental change in what it even means to be secure online. This right here, this is the one-sentence nightmare for every cryptographer and security expert on the entire planet. I mean, just think about that for a second. Imagine a single master key that could unlock every digital secret, every bank transaction, every government file, every private message you've ever sent.
And this isn't science fiction. Now, full-scale, powerful quantum computers, they're not here yet, but they're definitely on the horizon. And when they do arrive, they will have the power to just completely shatter the foundations of our digital security as we know it. So here's the crucial point. The really hard math problems that our current security is built on, algorithms like RSA and elliptic curve cryptography, well, it turns out those are exactly the kinds of problems that quantum computers will just eat for breakfast. The digital locks we use for literally everything, they're going to become useless.
Now, you might be thinking, okay, but if these computers are still years away, what's the big deal? Why the rush? And, that's a fair question, but it would be a huge mistake to think that way. The threat isn't some far-off future problem. It's happening right now.
This concept, harvest now, decrypt later, is the ticking clock in our story. Right now, as we speak, adversaries are just hoovering up massive amounts of encrypted data. We're talking stuff with long-term value, like government secrets, new product designs, financial records, and they're just stockpiling it, waiting for that day they finally get their quantum master key.
So you can see how this works, right? It's a pretty simple three-step play, but it's absolutely devastating. Information that is perfectly secure today becomes a completely open book tomorrow, or in 5 or 10 years. Any secret that needs to stay secret for a long time is already at risk. So, if our current systems are basically sitting ducks for a future attack, and the new quantum-resistant stuff isn't quite ready for prime time everywhere, what do we do? How do we build a bridge to get us to a secure future? How do we protect ourselves during this really awkward and dangerous transition period?
Well, the answer is something called hybrid cryptography. And it's this really elegant strategy that's being rolled out across the internet as we speak. It's not about ripping everything out and replacing it overnight. It's about building a robust safety net that actually combines the best of the old world with the best of the new.
Probably the easiest way to think about this is the two locks analogy, and it's actually super simple. Imagine you're putting two totally different, independent locks on the same door. One is a traditional lock, the kind we've known and trusted for years. The other is a brand new, futuristic lock. This is our PQC lock, which stands for post-quantum cryptography, and it's designed specifically to stand up to those future quantum computers.
And this right here, this is the golden rule that makes the whole thing work. To get through the door, a thief can't just pick one of the locks. They have to defeat both of them, two completely independent systems. And that gives us this incredibly powerful double-layered protection.
Okay, let's get a little more technical for a second and see how this whole two locks idea actually gets put into practice. Specifically, when two computers are trying to set up a secure secret key so they can talk to each other.
So check this out. This is basically how it works. First, use a classic method we've used for years to generate one secret. At the exact same time, you use a new post-quantum algorithm to generate a totally separate secret. Then, you just smush them together, you concatenate them, and run that through a function to spit out one final, super strong hybrid key.
This table makes it super clear why this approach is so powerful. Look, if a future quantum computer breaks the classical part, no big deal. The session is still secure because that post-quantum part holds up. But what if, and this is a real possibility, what if we find some bug in one of these brand new PQC algorithms? Well, we can just fall back on the old, reliable, battle-tested classical one. As long as just one of those locks holds, our data stays safe.
And it's not just for secret keys, by the way. The same exact logic works for digital signatures, the things that verify who you're talking to online. In a hybrid system, a certificate might need two signatures to be considered valid, one classical and one post-quantum. It just makes everything that much more trustworthy.
So you see, this hybrid approach isn't just some clever tech hack. It's a really clear, practical, and manageable path forward. It lets the entire global internet evolve without some catastrophic break in security.
And it's really not just about being paranoid about quantum computers. It's also a deeply pragmatic strategy. It allows everyone to migrate gradually, giving us time to test these new algorithms, and for companies to optimize their systems, all while we can still lean on the proven track record of our existing security. It's just a smart, conservative, responsible way to do it.
And this timeline here kind of lays out the whole journey for us. For decades, we've lived in that classical-only world. Right now, today, we're smack in the middle of that crucial hybrid transition phase. And then way down the road, once post-quantum crypto is fully mature and trusted by everyone, we might move to a world that relies only on PQC.
Ultimately, that's what this is all about. Hybrid cryptography is the mechanism that ensures our security can evolve instead of just shattering. It means that as the threats against us get more advanced and, frankly, scarier, our ability to protect ourselves evolves right along with them. Our digital world won't just break, it'll adapt. And that, right there, is how we defuse the quantum time bomb.